number 12, we have this graph. We have a graph where we have a point at 0, 0, and we have a point at 2, 4. And a line going through it. Okay, so we need to find the slope and the constant of variation. So the constant of variation is our k, and our equation is y equals kx, and our equation is y equals 2x. So what is our k value?
2.
2, right, because that is in the position where the k is. Y equals 2, and 2 is in the same place as k, so that means k is 2. So that's our constant of variation. And then, if we're looking at it to find the slope, our slope is also 2. So our slope is 2 as well. And remember, slope is the m in the y2 minus y1 over x2 minus x1.
Why is the m there? Anyway.
M is, we'll get to the point where we have y equals mx plus b.
Oh boy.
Which is the slope-intercept form. But we'll get there. This is the beginning of it. So if you take off that plus b, you get y equals mx, which is the same thing as y equals kx. So basically, we're tying all these things together. Okay, so that's number 12. So our answer is 2 and 2. So now let's look at 13. 13 is, we have a point at 0, 0, and we have a point at negative 1, negative 4. So we have these 2 points. And so the line's kind of going up to the right. And we have an equation of y equals 4x. So what is our k?
4.
4, right. And what is our slope, or our m?
4.
4, right. Are you noticing a pattern here?
Yes.
K and m are the same thing. So basically, only in this equation, in the direct variation, the y equals kx, well, that k is the same thing, but it's easier just to determine with this what our slope is and our m and our k. So 14, we have an equation of, come on, pen, y equals negative 1/2 x with a point at 0, 0 and a point at 2, negative 1. So what is our k?
Wouldn't it be 0.5?
Point negative. Negative 0.5, or just keep it as a fraction, negative 1/2. So, Justin, what's our slope?
Negative 1/2.
Yes, sir. Okay, so now number 15 is a little bit different.
Yeah.
Okay, so when you have something like this one, number 15, we have y equals negative x. Okay, and we want it y equals kx. And it gives us 2 points, so we can even figure it out from those 2 points. And the points we have are 0, 0, and 2, negative 2. So, can somebody tell me what number we have in front of this x? What would our k be? What number is in front of that negative, or that x?
Wouldn't it be a 1?
Yes, sir, it would be a 1. So we can write this as y equals negative 1x. Does that make sense, Sally?
Why would it be a 1? Because of the x, or?
If you have just a plain old x, there's always a 1 in front of it.
Oh, okay.
And so it's just implied. So
Or
whenever
positive?
variable, sorry, say that again, Justin?
Negative or positive?
It'd be negative because there's a negative sign there.
Okay, just checking.
Okay, good question. So then what is our k value?
-1.
-1. So what is our m value, or our slope?
-1.
-1. Oh, it's nice to hear you, Brian. I've missed you. Okay, right. So we have a slope of 1. We have a direct constant of variation of -1. Does that make more sense now, Allie?
Yep.
Okay, so that was 15. Now let's look at 16. We have y equals 3/2 x. So what is our k?
3/2.
3/2. So what is if our k is 3/2, our slope is
Oh, 3/2.
3/2. Right, it's the same.
I have a question.
Yes.
When we write our answers,
Uh-huh.
since we're showing all our work, do we write k equals 3/2, and then for slope, do we write
You can write m, because m's the variable that you use for slope.
Okay.
M equals 3/2.
Okay.
Okay?
That's what I've been doing. So.
Perfect.
So what does it equal?
M equals 3/2, and k equals 3/2. Okay, and the last is number 17. 17, we have y equals -1/4. So what is our k value?
-4.
-1/4. And then what's our m value?
-1/4.
-1/4. All right. So Allie, does that make a lot of sense now?
Yeah. What about the ones that we're doing yesterday, though? Like, are those any different?
Nope,
Or...
it's exactly the same.
Okay.
Okay, 18. We need to graph each equation, and we have y equals 3x. Okay, so this is exactly like example number 2. Okay, so where in this equation, y equals 3x, is our slope? Which part of it? Y equals 3x. And somebody just name the slope for me.
It'd be 3.
3. Exactly. Awesome. So you see how those first set of problems really made you understand where the slope is in this equation. So we need to rewrite this as a ratio. So that's step 1, is determine your slope. It's 3. Okay, but you can't really figure out what your rise over run is until you turn it into a ratio or a fraction. So we have to take our slope and turn it into rise over run.
3/1.
3/1. Right, exactly. So basically 3 is the same thing in fraction form as 3/1. So then 3/1 is our rise over run. 3 is our rise, how many we go up, and our run is how many, left or right. Okay, so that's step 1. We've determined what our rise over run is. Step 2, first thing we need to do is graph the point 0, 0. It's a great starting point, because remember, when you have direct variation, y equals kx, you always have a point going through 0, 0. Okay, so let that just permeate your brains for a second. Okay, so I'm going to pause for a second. Graph paper?
Yes.
Okay, so, and Rex, do you have 0, 0 plotted on your graph paper?
Mine is with Miss Han.
Okay. Can you, let's see here. Do you have any pages that you can give back to Justin so he can look at, like number 18, the graph?
I'll trade you.
Page, what, number 8, page 18.
Okay.
To the right.
Up 3, 1, 2, 3, and over 1?
Yeah.
And so what would that point be?
It'd be 3/1.
Perfect. 3, 1. So that's what you do to graph it. Up 3 over 1. So Allie, do you see that?
Yes.
How to graph that? Okay, Brian, how'd you do on that?
Good.
Okay, good. So then the next one is, let me give myself some space. Okay, so the next one is then number 20, y equals negative 4x. So, first things first, what's the slope?
Okay.
-4.
Negative 4, right. Negative 4 is our slope. So then, what is our slope in terms of rise over run as a ratio?
-4/1.
4/1. Brian, is she correct?
Yeah.
Okay, so Brian, will you help me plot this? So tell me the first place we need to plot.
So it was 4/1, right?
Negative 4/1.
Okay, so
What's our first point we need to plot?
okay, so we're gonna go down 4 and to the right 1.
Okay, but first, what's the first point we need to put on before we can go down from someplace? Where are we starting?
Oh, we need to plot 0, 0.
Okay, plot 0, 0. And then you said to go down 4. Okay, and right or left 1?
Right.
Right. Okay, exactly. So now, can you tell me what the location of that point is? You go down 4, right 1.
-4, 1.
Yes.
I'll do the folded page in between.
Okay, so
Okay, that's that one. So that's number 20. And so I'm not in, so 22 and 24, I'm going to pause for a second, start recording. This is write and solve a direct variation equation. So it says, suppose y varies directly as x, and y equals 28 when x equals 7. So basically, whenever it says suppose y varies directly, that should trigger, oh, it's a direct variation. And then you use that y equals kx formula. So that's something to remember when you say it says, suppose y varies directly as x. You go, oh, that's a direct variation. So then it tells us that y equals 28 when x equals 7. Okay, so we know all these pieces of information. So you start with your direct variation formula, which is what? What's our direct variation formula? The one we've been using. It's with a y. Maybe it has a k, maybe it has an x in it.
Is it the long one that we've been using?
The short one is that really short equation we've been using.
Y equals kx.
Thank you. That's the direct variation equation. Y equals kx. Okay, so we know y equals 28 and x equals 7. Can somebody set this up, plugging those numbers in into y equals kx?
By the way, I don't know where we are. I'm trying to
Page example 3 on page 198.
I think it's B 198.
B 198? Okay, that would make sense.
They've also got it on 200.
Yeah, 200 is the check your understanding.
Oh.
Yeah,
I found it.
Example. Okay. So now we have this y equals kx, and we know y is 28 and x equals 7. Can somebody plug in those numbers and tell me the equation? Y equals 28, x equals 7. Okay. Out loud. What do you guys think? Just plug in your numbers.
Let's see. 28
Yep.
equals 7.
But we have that k in there because it's y equals kx. You have to take into account all the pieces. So we're close.
28 equals 7x.
7k.
Oh, 7k, sorry.
Because our x equals 7. So 28 equals 7k. Does everybody understand and agree with that?
Mm-hmm.
Yeah, because we're just plugging those
Yes.
numbers in. And now we're looking for our value of k. So now we need to solve this and get what our k equals. So basically we're looking for the constant variation. We're trying to find out how it varies, which is also our slope, right? So how do we solve for k if we have 28 equals 7k?
Divide.
Right. What are we dividing by?
28 divided by 7.
Yep, 28 divided by 7. So what is k equal?
4.
Yes. So 4 equals k. So that's our answer. It's asking us to find what it varies by, and it varies by 4. So the direct variation equation. Okay, so now we have to look at that. Okay, k equals 4, but if we wanted to graph this, we have to put it back into our original equation, the y equals kx. So instead of having this specific point at 28 and 7, the y equals 28 and x equals 7, we put this 4 in for a k of our original equation. So we get y equals 4x. We're putting it in for k. Okay, think about that for a second.
I think they have down the wrong number.
We're looking at 3a.
Oh, okay.
Okay, so basically, do you guys understand what we did there? By knowing the y equals 28 and the x equals 7, we were able to come up with the direct variation equation, which we can then, you guys just plotted from that. You find your slope, you plot 0, 0, and then you can graph it. So by solving that, we were able to find k, then put it into our original equation of y equals kx, and then we come up with our equation y equals 4x. Okay, let's do another one. So I'm going to give you one to do. Suppose y varies as x, same thing. So if y equals 27, when x equals x equals 6. Okay, so now we have y equals 27 when x equals 6. Let's put this into our y equals kx equation. What do you guys think? What does your equation look like? We're putting it into y equals kx. Y equals 27, x equals 6.
27 equals 6k.
27 equals 6k. Fantastic. Okay, now, Rex, tell me what our 6k, not 6x, 6k. Okay, so now, Rex, tell me, how do we solve for our k?
Divide the 27 by 6.
Yes, sir. Let's divide the 27 by 6. And you can use a calculator if you want to. And what is 27 divided by 6? Okay, divided by 6, divided by 6.
$4.5.
You got 4.5?
Yeah.
4.5. Okay, so,
That is.
yeah, 4.5. But you know what? Because we're doing direct variation and we want to figure out rise over run, how about this in terms of in a fraction? Because if we have 27 over 6, can we reduce this to a simplified fraction? Is there a common factor between 27 and 6?
There's not a common. There.
3.
3. 3. There's a number 3, because we can reduce this fraction by taking a 3 out of our numerator and denominator. So what would that look like? So if you
9 halves.
9 halves. 9 halves, right, is our k. And the reason we want to leave it in fraction form as opposed to the decimal, like we did first, is because 9 halves is already set up in rise over run. So it's easy to graph this. So the rise over run, first we plot are 0, 0. And then we could our rise would go up 9 to the right 2, plot a point. Does that make sense? Of why we would keep it as a fraction?
Yes.
Okay, so now if we know our 9 halves k is equal to k, plunk that into our y equals kx formula so we know our direct variation equation. So what would that look like? So just put in that 9 halves for the k, and then you're done. Y equals what?
9.5. Okay.
Or 9 halves.
9.2, or, yeah.
Not 9.2. We're keeping it in a fraction form. 9 over 2?
Yeah, that's what I meant to say.
Right. 9 over 2 what? So we have y equals 9 over 2
X.
x. And that's the direct variation equation. All right. Okay. So that is that. What I'd like you guys to do is you guys are going to do 4 problems. Well, actually, before I do that, I want to do one more step. We're going to do one more step. So you know how we just put it in and we figured out what our let's see here. We figured out what our y equals kx equation is. Okay. So what if we have this y equals 9 halves x, and then it says when find x when y is 45. When y equals 45. What do you guys think we would do with that? If we have this equation now that we found, y equals 9 halves x, and it tells us to find 45, what would we do with that 45 if we're trying to find our x? If it tells us y is 45, and we have an equation, y equals 9 halves x.
Replace the y?
Yes! Let's replace the y with the 45. So now we have 45 equals 9 halves x. Okay, so now we have just this x variable. So, Justin, tell me what we do.
Now we divide.
Right. So how do we divide this fraction?
We put it into like a decimal form.
We don't put it into decimal form. We flip it over and multiply, right? So divide.
It is multiplied to the x.
What?
It is multiplied to the x.
Right, but we want to divide it from the x, and we want to multiply it and we want to divide the 45 by it. So basically, we're dividing the 45. So we have 9 halves divided by 45 equals 9 halves x divided by 45. Oh, sorry, divided by 9 halves. My thing's not working. So, how do we divide a fraction?
You have to turn the other number into a fraction.
No, you flip it over.
Flip
it over and multiply. So on the left.
So it'd be 2 9.
Yep, exactly. So on the left we'd have 2 9 times 45 equals x. Because when you're dividing something, that's how we move it over. We're left with just x on the right side. So now we have 2 9 times 45, and how do we multiply that? We can, like Justin said, turn that 45 into a fraction. So we put it over 1. So now we have 2 9 times 45 over 1. Now you multiply your numerators and then you multiply your denominators. So what's 2 times 45?
90.
Yes, sir. And then denominator is 1 times 9.
9.
9. So now we have 90 over 9 equals x. Can we easily reduce that?
That would equal 10.
Yep, so 10 equals x. So basically, it's saying when y equals 45, our x is 10, or we get the ordered pair 10, comma 45. So we're just coming up with ordered pairs.